Okay, chapter 10. Tangents to circles. Anyone know what a tangent is?
That one thing we did.
You guys have heard when people are talking and someone says they went off on a tangent? Have you heard that saying?
I haven't heard it.
No, what it means is like if you're talking about something, if they go off on a tangent, they just switch directions and talk about something different.
Oh.
So, everyone knows what a circle is, I hope. A circle has a center. The definition of a circle is the set of points equidistant from one single point. Because if you had a point and then you measured out like 3 inches in all directions, and then you kept on putting points that were all 3 inches in all directions, pretty soon, yep, it would be all the points would be so close together it would form a circle. So, when you name a circle, it has a center, and the abbreviation to name a circle is just a little circle with a dot in it. This would be called circle A, because the center is A.
Oh.
A radius, I think everyone knows what a radius is, I hope. Halfway across, right. So, a radius is from the center to any edge. A diameter then is from edge to edge through the center. So BC is a diameter. Okay? So the diameter is just how wide it is. But it's got to be through the center. A chord. Now here we're getting into something that's, I don't know if you've probably ever learned probably what a chord is, but not a secant. A chord is a segment from edge to edge. So technically, a diameter is a chord. Because the diameter goes from edge to edge. It's just diameter is a more specific name because diameter, if it says it's a diameter, you know it goes through the center. A more common chord that you see would be something like this. DC is a chord. Okay? What we're going to end up doing with chords is if you drew a radius through the chord, it forms a 90. Right? So eventually, what does this form right here? So yes, we're not done with right triangle stuff. There's more right triangle stuff in circles.
That's a weird cut.
Okay, a secant. A secant is similar to a chord, except it's not a segment, it's a line that intersects a circle twice. So that means it has to go through it 2 times, not just once. Once it just barely touch. So if this were line DC, you can use that as a chord and a secant, you just got to label it correctly. The secant would be labeled like this. DC with a line above it because it's a line, so secants always have the line. The chord is just DC. If there's no symbol above it, that means it's a segment. You can put the segment symbol above it, but that's the one where you wouldn't need it. You can write it like that or like that. Okay? So secants cut all the way through, chords start and stop. And then a tangent. A tangent touches a circle. Not 2 times, but at 1 point. So if you pick a point and draw a tangent, or a line that touches just that point, that's called a tangent. So once again, if you draw a radius and a tangent, they will always be perpendicular. So what we're going to get is more right triangles out of that stuff. So, radius, diameter, everyone knows. Chord, secant, tangent, you're gonna have to remember what those are. Chord starts and stops, touches each side. Secant cuts through it in two spots. A tangent touches at just one spot. Okay. Tangent circles. If you know the meaning of tangent, tangent just touches at one spot. So if two circles are tangent, that means they're just going to touch at one spot, right there. Okay? Concentric is when you've got a circle and then another circle touching it on the inside, like that. A common tangent. A common tangent is if you've got two circles and I draw a tangent that touches both of them, like this. Oop, pretend it touches there. So there's a common tangent because it touches them both. And I could draw one here. There's another common tangent. These are called common external tangents. You can also have common internal tangents. Can you picture how the common internal tangents would be? They would go like this. That touch there and there, and there and there. Okay? So the internal, common internal just goes in between them. The common external is outside of them. Everyone knows what exterior is, right? Outside of a circle. The point of tangency is the point that the line touches at one spot. Okay, so every tangent line has a point of tangency, and that's just where it touches the circle. So, what would best describe segment CG? Radius, easy one. Segment EG, diameter. It is also a chord, but diameter best describes it. And then the line AD. What? No.
Touches one point.
What's that called if it just touches at one point?
Oh,
Tangent. If they asked, line FH here is a secant because it's a line that cuts through. Okay, so here's the things that I just told you about. If you've got a tangent and a radius that's connected to the point of tangency, it will form a 90-degree angle. They're perpendicular to each other. Okay? So then the converse of that is if you see a tangent and a line here that is 90, you know that that's a radius and this is a tangent. So if they form a 90 and touch at one point, you know that that's a radius. And then if you've got two tangents that intersect, it doesn't matter how you draw them. If I drew one like this and one like that, here's the point of tangency, here's the point of tangency, here's where they intersect. Here's the point of tangency, here it is, and there's where they intersect. This distance will equal that distance.
We did this in the picture.
You did it what?
We did this in the picture.
Not the tangents we didn't. So in here, this line right here would equal this line right there. If this is 5, that's 5. So what's going to happen, again, I'm just jumping ahead to show you. If I connect this point to there, what do you know about these two lines right here? They form a 90. And if I draw that, what does that make? A right triangle. So Pythagorean theorem is going to be used quite a bit in those. In fact, right now. Okay, here they've got you're standing at R, which is 4 feet from a fountain. The fountain's a circular fountain. They drew in the radius and the radius here. So, this is a point of tangency. It says you're 8 feet from a point of tangency. So since that's a tangent, that means that's a 90. So you've got a right triangle right here, and we're gonna figure out the radius of the circle. So, if I redrew this, this is the radius, this is 8, and how long is this piece right here? How would you represent this, the hypotenuse? R plus 4. Because from here to here is the radius, and then it's 4 more feet, so that is R plus 4. So, since it's a right triangle, we know that the leg squared plus the other leg squared equals the hypotenuse squared. Now, this is one of them that you have to know how to square from last year in algebra. R plus 4 squared, you can't, this is the most common error. You can't just square the R and square the 4. 16. That's close to being right, but it's not completely right. Remember, what does it mean to square something? Take it times itself. So R plus 4 squared means I gotta take R plus 4 times R plus 4. Okay? When you've got a quantity times a quantity, you have to FOIL, if you remember foiling. You take the first times the first, the R times the R is R squared. The outside times the outside, and R times 4 is 4R. The inside times the inside is 4 times R is 4R. And the last times the last, 16. It just spells out FOIL, but what you do is, remember, if you've got a number times a parentheses, you gotta distribute it through, right? Here there's 2 things. So all you gotta do is take this times both of them and this times both of them. Take the R times the R times the 4, which is first and first, outside and outside. And then take the 4 times both, which is inside and last. So that's how they come up with FOIL. So in this now, those 2 are like terms. So it would be R squared plus 4R and 4R makes 8R plus 16. So that's just this part right here. Plus another R squared equals 64. Oh, I put them on the wrong side, I'm sorry. Let's remember that it's R squared plus 8R plus 16. When I drew it over here, I didn't draw them in the right spot. The 8 is a leg. The 8 is a leg right here, and the R plus 4 is the hypotenuse. So I put them in the wrong spot. So it's R squared plus 8 squared equals R plus 4 squared. So we know this is R squared plus 64, and we just figured this out. It was R squared plus 8R plus 16. So now you gotta solve it. These are the only types we will solve, because what happens when you get the R squareds together? They cancel. Subtract R squared, subtract R squared. So you're left with 64 equals 8R plus 16. So we just subtract 16. And then divide by 8. And you get 6 for R. So the radius is 6 feet. So those are a little longer because you've got to FOIL. But they're real easy to solve once you do. So this one also, as long as you remember the rule, it's a simple one. It tells us AB is tangent to circle C at B. AD is tangent to OC at D. So since these are both tangents, what do you know about those two lengths? They're equal. So x squared plus 24 has to equal 49. So when we solve it, get the x by itself, you subtract 24, and then square root. So x is 5. So this one also, since these are both tangents, these are equal. 4x plus 27 has to equal 5x squared plus 4x minus 18. It looks complicated, but it's not, because when you get the x's together, they'll cancel. Subtract 4x, and they cancel. So you got 27 equals 5x squared minus 18. So add 18, you get 45 equals 5x squared. Divide by 5, 9 equals x squared. Square root it, and you get